Hi everyone, this is Andrew at the Wyoming Dinosaur Center, and this is Fossil Friday. A lot of times in science, we have to look for modern parallels in order to understand things that are happening in the ancient world. What we just did was a highly scientific experiment that has to deal with this remarkable fossil today, the topic of our Fossil Friday. This is an ammonite shell. Ammonites are a pretty simple animal to understand. Just picture an octopus or squid coming out of this end, and you got the basic idea with this nice curly Q shape. This is a rather large ammonite, and a very pretty one, but we'll save that for another episode. But you'll notice this symmetrical pattern of holes along the top of this shell. Now, when you see a symmetrical pattern of holes like that, you think the obvious thing, this is a bitten ammonite. Somebody who's bit into this guy and left these tooth marks behind. Now, you think that's pretty simple to explain, but you can see lots of structures in nature that could explain something like this on the shell of an ammonite. What we have to do as scientists is try to figure that out. So let's go through the process. The first thing is, what animal has a bite mark like this that would probably want to bite into a tasty morsel of an ammonite? And the solution is a mosasaurus. You've seen the mosasaurus in Jurassic World. They weren't really that large. But anyway, they are a very common marine reptile, and they have the exact kind of bite pattern we would expect for something like this. But then we have to think about how mosasaurs bite into things, which brings us to our highly scientific chart of mosasaurus bite patterns. Ta-da! I made it myself. So mosasaurs, many different species have many different types of teeth, and all of these teeth leave a specific bite pattern behind. So let's start with cuts. Lots of mosasaurs have teeth that are designed to cut, just like reptile and dinosaur teeth. So a cut, something like that. Notice what's left behind as a result of that. Then we have pierce. Many mosasaurs have teeth that are much sharper, designed for piercing things. Ooh, got my arm there. Notice what's left behind as a result of that. And then finally, we have crush. Many mosasaurs have teeth that are designed to crush. And notice what is left behind from that. So we've established the three types of mosasaur cutting teeth. Now we have to look at the various bite patterns. So first we have cut, a long, ragged line with lots of little bits left behind. Not exactly what we see in our ammonite. So let's try crush. That nice big hammer mark. Not the same thing we see there. But if we look at pierce, we see the same style of lines and holes that we see in here. So this was an ammonite that was bitten by a piercing mosasaur, or so we can think. But the next step would be we have to look at the shell itself, which we did using a CT scan, and we can see that on the inside of the shell, when you look at it from this side, it looks pretty simple, those holes. In fact, pretty close. You can see those holes, but if we flip it over, we should expect to see on the opposite side this same type of kind of reverse W pattern, the shell kind of breaking in on itself. And when we looked at the shell under the CT scanner, we saw the same result as a result of that. So we think we can say pretty conclusively that this is a shell that was pierced and actually chewed on a little bit. Somebody really ground their teeth into these holes by a mosasaur with piercing teeth. And so how did we figure that out? By looking at the patterns, but also by testing this with a real-world example. This is pretty similar to ammonite shell, and we have the ammonite shell right here. A lot of times you can test these real-world principles and determine what the actual results would be. Science in action. Well, that was a pretty interesting episode, if I do say so myself. So until next time, this is Andrew at the Wyoming Dinosaur Center, keeping your Friday fossiliferous.